So in this video, we are going to continue our discussion on chapter number 8, quadrilaterals. So the topic of this video is four conditions for a quadrilateral, Q dot is quadrilateral, to be a parallelogram. Now we all know what is the definition of a parallelogram. A parallelogram is a quadrilateral where opposite sides are parallel to each other. However, in a reverse scenario, if you are given a quadrilateral and if you are asked to prove whether it's a parallelogram or not, then there are four conditions. If any one of these conditions are satisfied, then we can confidently say that the given quadrilateral is a parallelogram. So we're going to see these four conditions in this video. So let's start with condition number 1. So here is the condition number 1. Let's read the statement out. If each pair of opposite sides of quadrilateral are equal, then it is a parallelogram. P dot is a short form for parallelogram. Okay, so the key word here is equal. Okay, opposite sides of quadrilateral are equal. So what does this mean? So let us draw a parallelogram first. So no, sorry, let us not draw a parallelogram. Let us draw a quadrilateral. So if you are given a quadrilateral, okay, something like this, and if the information given to you is that the opposite sides are equal to each other. So let's say AB is equal to CD and AC is equal to BD. If this is the piece of information that is given to you about a quadrilateral, then you can very confidently say that it is a parallelogram. This is a simple first condition for a quadrilateral to be a parallelogram. Now, if you note this statement is in fact a converse of a property of a parallelogram. So, in the previous video, we have seen, we have seen three properties of a parallelogram. So, one of the properties was this. Let me highlight it here. So, this was the property, okay, that in a parallelogram, opposite sides are equal. So, if a parallelogram is given to you, then the opposite sides are equal. Okay. Now, in this condition, it's exactly opposite. Here we say that if the opposite sides are equal, then it is a parallelogram. So, not only this condition, but even the next conditions you will see are the reverse, are the converse of the properties of the parallelogram, which we saw in the previous video. Okay. So, let's go ahead to our second condition of a parallelogram. Let's keep this parallelogram for reference. Yes. Now, let us remove this. Okay. So, as you can see, this statement is exact copy of the statement number 1. Okay. Only with one change. Instead of sides, it says angles. Let's read the statement out. If each pair of opposite angles of a quadrilateral are equal, then it is a parallelogram. So once again, let's highlight the keyword. Opposite angles are equal. Okay. What does this mean? So again, I'm going to use this parallelogram. So this is my opposite angle, angle B and angle C. Okay. And angle A and angle D. These are my opposite angles. So the statement says that if the opposite angles of a quadrilateral are equal, then the quadrilateral has to be a parallelogram. Once again, this property is the converse of this condition is a converse of this property. What does the property say? In a parallelogram, opposite angles are equal. So the conditions that we are seeing for a quadrilateral to be parallelogram are the converse of the properties of the parallelogram. So this was our condition number 2. Now let's go to condition number 3, and I'm going to remove this slide. Yes, let's read it out. Condition number 3 reads, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Now let's highlight the keyword, the diagonals, and they bisect each other. What does this mean? So let's quickly draw a quadrilateral. So let's say, okay, let's use straight lines. So let's say this is my quadrilateral. Okay. Yes. Okay. Yes, let's erase it a bit. Okay, fine. Now, the condition deals with the diagonals of a quadrilateral. So let me try to draw the diagonals of a quadrilateral. So this is the diagonal number 1. Okay. What is the definition of a diagonal? A diagonal is a line which connects the opposite vertices of a quadrilateral. and this will be another diagonal of a parallelogram. Sorry, another diagonal of a quadrilateral. So I'll give different names. I'll call this P and Q. Okay. Now the statement reads, if the diagonals of a quadrilateral bisect each other. What does bisect mean? Bisect means this point of intersection, let's say O, will be the midpoint of the diagonals. So AO will be equal to OB and PO will be equal to QO. Okay, so these diagonals, they bisect each other at this point O. The meaning of bisection is divide a diagonal into two equal parts. Okay, so if the diagonals of a quadrilateral bisect each other, then we can very confidently say that this quadrilateral has to be a parallelogram. And once again, this condition is the reverse or the converse of the previous property of a parallelogram, which reads, the diagonals of a parallelogram bisect each other. So if a parallelogram is given to you, the diagonals will bisect each other, and the converse statement is, if the diagonals bisect each other, then the quadrilateral has to be a parallelogram. Yes. So these are the three conditions we saw, which are in fact converse of the properties of a parallelogram. Now let's see the last condition, which is not the converse of a property of a parallelogram. The condition reads, if a pair of opposite sides is equal and parallel, then the quadrilateral is a parallelogram. Now what does this mean? Okay, let's draw a new parallelogram instead of reusing it. So if a quadrilateral is given to you, this is a quadrilateral, okay, and the condition is, let's highlight the condition, the opposite sides are equal and parallel. Okay, what does this mean? That this side is equal to this side and also they are parallel to each other, and this side is equal to this side and also they are parallel to each other, then it is a parallelogram. Now this is a very obvious and quite intuitive condition, because the basic definition of parallelogram is opposite sides being parallel to each other, and that is the exact condition that a given quadrilateral has. The opposite sides are equal and parallel, then it's quite obvious that the given quadrilateral has to be a parallelogram. So thus, in this way, in this video, we have seen four different conditions. Okay, four different conditions for a quadrilateral to be a parallelogram. Now, these conditions will be very useful in solving our exercise problems, because in many of the exercise problems, they will give us certain conditions in a quadrilateral, and we'll have to figure out if the quadrilateral is parallelogram or not.